Good afternoon. Welcome back to the chemical bonding and the molecular structure. Yesterday we have seen the sigma bonding. In the sigma bonding again, SS overlapping, SP overlapping, PP overlapping, and pi bonding, and the strength of the sigma and bonding, general properties of the covalent bonds, exceptions like diamond, graphite, and all. Now we will see interesting topic of the valence bond theory, hybridization. So this will give the exactly the all the solve the most of the problems of like bond angle or shape of the molecule and all. Now general just for the sake of the more understanding what is hybridization, suppose rice atta will have the gives the dosha. Normal atta that is the will give the what you call atta, both are will be different. But if I am mixing equally, perfectly, and all these things, the final will come in. Is neither it will be atta nor will be the rice powder and all these things. So what I want to say here, the orbitals are going to be mixed, pre-mixed before the electron is added or before bonding is this. Remember that there are some salient features or some rules in the hybridization. One has to this thing. Where or when the hybridization will start? Certain number of the certain number of orbitals only participating in the hybridization, but not electrons. Electrons are universal, that there is no hybridization for the electrons. Valency orbitals are only participating. That too, this is one condition. Second condition, what is the condition? Participated, suppose 2 or 3, whatever the numbers are participating in the atomic orbitals participating in the hybridization, equal number of hybrid orbitals are formed. Number of atomic orbitals equal to number of hybrid orbitals. This is second. Which will participate only in the valency, not in the first shell, second shell and all. Whatever is the valency. Valency, that is nothing but equal energy. That means 2s and 2p, or 3s and 3p, or 3s 3d, like that only. That means valency, outward, equal energy, atomic orbitals are participating and use the equal number of orbitals. Then whatever it is formed, all the orbitals, hybrid orbitals, suppose 4 atomic orbitals are mixed together, 1s, 1p, 1d, like that, all these form mixed together, and one hybrid orbitals are 4 are formed. All the 4, that means all the equal number will have the same shape and size and energy. More the shape and energy is same for the hybrid orbitals. S and P, suppose they participate in the hybridization. Initially S will have different shape and S will be the circular cylindrical shape, and this will have the dumbbell shape and all. But finally the mixed orbital, hybrid orbital will have the same shape, energy, same size, everything is same. That is they are more effective for formation of they are more effective for bonding. And what is the shape and size? They will form in such a way that repulsions will be hybrid angles will be different in such a way that repulsions are minimum. Okay, then sometimes electrons may be promoted to neighbor orbital, These are some of these things. And how many varieties are there? sp hybridization is there, sp2 is there, sp3 is there, sp3d is there, sp3d2 is there. These are the normal common this thing, and more these hybridizations are involved in the organic chemistry. Okay, not that it is not there in the other these things, but lakhs of compounds are there in this hybridization compounds and all these things, the organic chemistry. Actually, that is has come from the requirement has come from that side. Okay, now we will see first what is sp. Means one s orbital plus one p orbital. These two are atomic orbitals. They are mixing together and they form a hybrid orbital that is called sp orbital. Each one is called as a sp orbital. This is having a 50% s character and this is having a 50% p character. And which p? There are three p's normally. P means px, py, pz. Pz only normally first will interact with the s, not the py or px. So the resultant will be the s and p orbital. That will be this thing. A small example we will see. Okay. Example is, we will going back again to the why barium chloride is linear and all these things. Beryllium chloride. Beryllium is 4. That means actually 1s2, 2s2. 2s2, but here this 2s2 fellow is jumping as like this. 1s2, 2s1, 2px0, 2py0, 2pz1. That means this one electron is going into the same orbital of the 2p, where in the z this thing x 2px 2py is 0 0 and z. This 2pz and this 2s1, this is in inner shell. This 2s fellow and 2pz fellow are making hybridization and you are getting a one sp orbital. This sp orbital of the beryllium. See, it is all within the beryllium only. We are not talking about the chlorine, which is forming and with this thing. This sp orbital, that is beryllium, will be a 50% s and 50% p character, is forming a 2p orbital of the 3p orbital of the chlorine. 1 chlorine, 2 chlorine. It is a linear structure with a 180 degree angle and all this thing. So this is very clearly explaining the why these shapes are equal, why this angle is 180 and all in the beryllium chloride sp hybridization. Then next comes to the sp2 hybridization. We will see one more. That is the immediately boron trichloride. Again here boron is 5. 5 means 1s2, 2s2, 2p x0, 2p y0, 2p z already 1, because it is already 1, 2 plus 2 plus 1 is there. But here one more fellow will go into the next 2p this thing. So finally it will become 1s2, 2s1, 2px0, 2py1, 2pz1. This 2 p orbitals and 1 s orbital, that means 1 s plus 2p orbitals is giving a hybrid orbital of sp2. Meaning of sp2 is 2p orbitals and 1 s orbital. The characters are like this, that is 1/3 will be the s and 2/3 will be the p character. This is ready to form with the boron, ready to with chlorine, and that will form a boron trichloride compound that will be in the shape of trigonal. That will be the what you call, it is a trigonal planar and the angle is 120, very clearly, both matching with theoretically and matching with the experimental value, that is sp2. Okay, square is nothing but 2p. 2p is similarly. Now we will go to the sp3. sp3, the example is normally methane. A general example is, take the carbon. Carbon is 6. 6 means 1s2, 2s2, 2p, 2. But 2p2 fellow will be like this: 1s2, that is the internal one, 2s1, 2p1 x, 2p1 y, 2p1 z, 1 2 3, 2p1. So 3p and 1s. This 4, 1s plus 3p's, total 4, are hybridizing and giving a sp3 orbital. This name is sp3, that means in this character of the 3 is character and 1s, resonant 4 orbitals are coming, but all the 4 are equal in shape and sp3 orbital. Those sp3 orbitals are forming with the hydrogen, and methane compound is forming. That is nothing but your molecule is by combination of the this thing. This will be 109 degrees instead of 170 degrees. It is will be bipyramid structure, tetrahedral, not this thing. So we will say some more this thing why the shapes and all other shapes, like the double bonds, when it is the double bonds are triple bonds are forming and all these things. Okay, thank you.